Um, and I believe Robert is here. Um,
That is
Robert,
true.
oh, there he is. Great. And Robert has joined us to talk, I think, about marine engineering. Is that right?
I have a very unusual job and degree. I have a master's in ocean engineering.
Ocean engineering.
Uh,
Great.
and we do not build oceans, in case somebody's wondering. So it's a pretty broad field. Um,
Um,
Go ahead.
oh, I was going to say maybe you could introduce yourself and your relationship to Cabrillo to the students, and then talk to us a little bit about what you do. Yeah.
Yeah. Well, I'm Rob Wyland. Um, I did not go to Cabrillo. I am an instructor at Cabrillo. I teach Engineering 35 lab statics, and I've also taught the course. Um, I primarily signed up to teach at Cabrillo because I wanted to give back to the field of engineering. Um, and to be honest with you, I relate to engineers more than I relate to scientists, although I work with a lot of scientists. Um, they are different, and I like engineers better. Just saying.
We're awesome. We have a different way of thinking, actually.
Yes, for sure. We have different goals in mind.
Yeah. And tell us about what you do when you're not at Cabrillo.
Right now, I work for the U.S. Geological Survey. I work at their marine facility, which is on the west side of Santa Cruz. It's in, for those of you familiar with Santa Cruz, it's in the Wrigley building, the old Wrigley Gum building, which is now the University Business Park. Large building. We probably occupy, I don't know, I'm going to guess a quarter of the building. So, and I go there most days. In COVID times, only when I have to. I have to get approval to go into the office, but I can go in. I was in today, working on a few things.
What does the work for USGS entail?
This is a really tough one for people to grab their minds on because all of my ocean engineering career, and I did have a career earlier as a manufacturing engineer for a couple of years. I chose to go into ocean engineering because I loved engineering, but I really hated working in factories. So I chose ocean engineering, and sort of on a lark, I heard about ocean engineering as I was going to a baseball game, Boston Red Sox game, back when they were terrible. And I was with a group of friends, and one of the friends of a friend said that she was going to go into school for ocean engineering, and it just lit all the right things for me, and I applied, and I was there a year after she was, University of Rhode Island. Ocean engineering basically takes all the other engineering disciplines and applies them to the ocean, which is a unique environment. It's similar to what one might say is an aeronautical space engineer. They have special things that they worry about, although all the same principles of mechanical engineering, electrical engineering, all those things apply in space, but they also apply in the ocean, but they are applied differently. So my role as an ocean engineer for over almost 35 years now has been to support scientists in their research goals. So that means everything from designing equipment that hasn't been made before, operating the equipment, helping them make the measurements, going into the field. One of the best things about my job is that no one day really looks the same as another day. One day I might be driving a very large truck up the coast with a whole bunch of equipment to get on a research vessel for 3 weeks, and then I'll be on the research vessel for 3 weeks, and then we'll do all the opposite, come off, and then we'll build new equipment. We'll examine the data, decide whether we made the right choices on equipment and how to change equipment, and there's a lot to it. It's very varied, and I enjoy that the most.
That's really exciting. So you wanted to get out of the factory, you said, and so then you went into ocean engineering, and this finds you out in the field more. Is that correct?
Yes. Yeah.
Okay. And then, do you have students aboard your research ships ever?
Well, my very first ocean engineering job, which has actually been for the majority of my career, was at the Naval Postgraduate School in Monterey. So that's just down the way here. And of course, we had lots of students around all the time. So I was always working with students in some form or another. Um, and they would come along on experiments. A lot of my work at the Naval Postgraduate School was what I call beach work. We were on beaches, studying beach erosion, beach dynamics. A lot of it had to do with, like I said, erosion, but also the effects of global and climate change. A lot of that has been a part of my career for 30 years, 35 years in some form or another. But yeah, so students there at the USGS, we are not an academic institution. We sometimes have, what do they call it? Mendenhall students. These are usually PhD students that are there after they've gotten their PhD, but they haven't really become a full-fledged PhD. It's sort of like a internship for doctors. Once they've got their degree, they don't really let them be doctors yet.
Mm-hmm.
So we have students of that nature, and sometimes we have student interns who come and hire. In fact, we've had a couple of Cabrillo students work alongside us.
Oh, that's really great.
So
And how has COVID impacted your work environment?
um, since I spend a fair amount of time what I call operational, which is out in the field, it's been a big change. For the first couple of months, we didn't do any of that. I also often work in the machine shop, and so I wasn't granted access to the machine shop for a while. So a lot of things changed quite rapidly, but we're finding ways around it. Of course, the regulations have changed. In fact, when I said I was in the office today, I was preparing our nearshore survey equipment, which is jet skis, to go out and survey Monterey Bay next week. They'll be out Monday, Tuesday, Wednesday, Thursday, doing surveys of basically the surf zone all the way from down near Watsonville up to Santa Cruz.
And what will happen with these surveys? What are they trying to accomplish? Is it for flood mapping? Is it for, I don't know, fish mapping? I'm making stuff up.
So this is what they call, and I have some pictures if you want to see pictures.
Yeah, show us, please.
Can I share a screen here?
Yes, you can. It's
Okay.
at the bottom, the green button.
Got it. I just wanted to know if I had rights.
Oh, yeah. And those of you who are listening at the class, please feel free to type questions into the chat. Oh,
So,
cool.
This is older experiment, but what we're trying to do is measure what's happening in the surf zone. And my son asked me this question, and I have a hard time explaining it because it's really the scientists who do this. But my role in this is to build all the equipment that you see in this picture and make sure that it does what it's supposed to do and works. What they're doing, I don't know if you can see my cursor, this vertical pole with all the little pointy things sticking off of it are basically instruments. The ones on the right-hand side are all instruments that measure velocity in 2 dimensions. And then the things on the left measure the amount of bubbles in the water. What we're trying to do is determine the nearshore circulation of water and how it moves sand around. And so these long-term measurements like we're doing next week, what they're doing is they're measuring where the sand is gone. And what they do is they do this every 3 months, year in and year out. And they can determine whether the beach is getting bigger or getting smaller, what are the effects of sea level rise. In this case, this picture here, it was funded by the Navy. The Navy was interested for 2 reasons. When they do amphibious assaults, they wanted to know if their vessels going into the salt would basically get swamped and carried away. When their soldiers got out, would they get carried away and all drown? There are some countries that were proposing, this was back in the 90s, they would fly overhead with airplanes and they would throw landmines out of their airplanes into the surf zone, and they would land in the surf zone. And so Of course, they don't stay there because the surf zone, as you can see, is quite dynamic, and the mines would move around. And so they wanted to know how long would it be until the mines had all moved to someplace else after an airplane had dropped them out.
Wow. Are the people in the photo, are they all engineers or?
In most cases, in most of my career, I'm the only engineer.
Oh.
I rarely work with engineers. Almost every one of these people is a scientist or a technician. I tend to be, as an engineer, at the top of the technician pile. But almost all of these guys are scientists. So I just want to show you, I have some other ones.
Sure.
Make this bigger somehow. Get out of the way.
And there's a question in the chat. Have you ever been to Antarctica?
I have not been to the poles, although I have designed and built equipment to go there, and it has gone there. To the Antarctic, the last thing I was doing at the Naval Postgraduate School was designing basically like a submarine. They went and they drilled a hole in the Antarctic shelf down through the ice shelf into the water, and we dropped a long cable, and then we were putting a instrument on there that would measure the salinity, the temperature, and the velocity, and the depth. And we had a small ballast bladder that would inflate and deflate, and it would allow the instrument to go up and down on that wire underneath the ice shelf. Eventually the ice froze up, but we had the wire also as like a radio antenna. So it would, as it went up and down between the bottom of the ice shelf and the bottom of the seafloor, it would transmit information into that cable up to the surface and then out to a satellite and then back to our office.
Is that instrument frozen in the ice? Is that what you said?
Yes, it's never coming back. Unless, huge logistics. That's half the reason why I didn't go, is they just to fly all the gear out to melt this hole into the ice shelf and put it all in, probably on the order of $500,000 just to get the people there and the equipment.
Wow. Okay. And that was a USGS project.
That was actually Naval Postgraduate School.
Oh, that was Naval. Okay.
Yeah, and the whole point of that experiment was to measure how much fresh water was melting from the ice shelf underneath and coming out. So by measuring the salinity at all those different depths, we could see how much fresh water there was. And by measuring the velocity, we could make a quantitative state of like many cubic feet of fresh water are flowing by this spot every day at this rate.
Right, you got a rate. More questions in the chat about this. What are your thoughts on Antarctica and the separating Amory ice shelf, and how deep do you do your research in the ocean?
When it comes to the ice shelf, like I said, I'm not a scientist, but it makes me very sad to hear these things. Like I said, I've been working on this stuff for 35 years. 35 years ago, when people would ask me, do you think climate change is real? Of course, we called it global warming back then, which was a terrible name for it.
Right.
But climate change, do you think it's real? And I thought at that time it was a fair question. The research was just beginning to be very informative as to what was really happening. And now to me, it's absolutely almost, I don't know how to describe it. If somebody asked me that question now, I feel as if they're goading me have a political argument rather than discuss the science. The science
Right.
is unequivocal. This is happening. It's going on, and it makes me cry because we've been doing this for 35 years, and the message is still not getting out somehow. That
because it's been politicized as opposed to left to education and science.
Yeah.
Basically. The other question was, how deep do you do your research in the ocean? That's an interesting one.
I hate to say this, I've been fortunate. Most of my stuff has been fairly shallow.
Okay.
And when I mean by shallow, it's less than 1,000 meters. My graduate school work, I was at 6,000 meters out in the middle of the ocean, Pacific, but most of my stuff is shallow. A lot of this stuff, like this picture you see here, is a picture of Duck, North Carolina. And we were again doing beach nearshore dynamics. that vehicle there would probably go out to, well, as deep as you could go without swamping the guys who were on the top of it. So not very deep. But most of it,
How would it
1,000
stay?
meters is as deep as I go.
Is it something that floats, or how does it stay erect with the wave action?
So this this vehicle is unique. It's called the Crab. This is at the Army Corps of Engineers Research Facility in Duck, North Carolina. And that vehicle at the top has an engine. It was a Volkswagen engine. They didn't think they needed much power when they built it. And they also wanted it to be light. So they have hydraulic lines that run down to these tires here, and they run little hydraulic motors that drive the wheels. And then they also have a turning wheel in the front. It's like a tripod. And the wheels are filled with water so they don't float. And it can drive out to, it's probably up to about the bottom of that little platform there. That little platform can go up and down. And what it's doing in this particular situation is it's dragging, you can see this thing on the beach, is a sled that I designed and helped build that was going to make a bunch of measurements out in the surf zone. And so they would pull this thing out, and we had a cable that went back to shore, and we'd collect data. And every now and then we would pull it a little further back in and make more measurements at different spots throughout the day. And then we would do that again the next day and the next day. And we did that for about a month straight, making measurements.
There's another question. Is the Monterey Bay the best place to do research like this, with everything needing depth being so close to shore?
The Monterey Bay area is fantastic for oceanographic research. That's half the reason why the USGS is here. They used to be in Menlo Park, at least the oceanographic portion of the USGS used to be in Menlo Park, and they came to Santa Cruz specifically because there are so many other academic institutions and research institutions doing oceanographic research here. Just to name a few, there's, of course, you all know the Monterey Bay Aquarium Research Institute. There's the U.S. Geological Survey. There's the University of California, Santa Cruz has a thing here. Johns Hopkins has a university station in Monterey Bay. The Naval Postgraduate School does some, and of course now Cal State Monterey Bay also does oceanographic research here. So it's fantastic. In the sense of it being deep, it depends on what you're trying to do. I have done some work trying to measure the underwater landslides in the Monterey Bay Canyon, putting out moorings, measuring sediment flow and rate of current flow, and also seismic stability, as well as mud samples.
So with all of those institutes, is there a lot of collaboration that takes place?
Yes. It's a fairly small community, and everybody sort of starts to know everybody at this point. Yeah, when I go to a conference or a meeting, there's a good chance I'll know 4 or 5 people always.
Okay.
It is on the technical side, probably a little less sharing going on. The scientists seem to have a much better venue for doing that. They go to conferences more, they publish more papers, but ultimately the technical people, the engineers and such, all share ideas as well, because we're all looking for a better way to do the same thing.
Other questions from the class? Is that you?
That's not me, but this is one of the things that I have worked on. I've worked on maybe 4 or 5 versions of this. This is what they're doing next week in Monterey Bay. This is a jet ski, and we have a computer mounted on the back, as well as a sonar system. There's a monitor to the right of the jet ski operator, and we also have a GPS. You can barely see it on the back there. And so what they do is they basically drive around, going in and out of the surf zone, making bathymetry measurements, water depth. And the reason we chose a jet ski is because it's really the only thing that can survive in this environment. We have tried in the past, and I've been a part of this, of people walking out with staffs into the surf zone trying to make depth measurements, and they just get clobbered by waves.
Oh, yeah.
And then they've tried to drive big boats in as close as they can, and it always gets hairy and dangerous.
Yeah.
And so jet skis have been been the mode of choice for this measurement for about 25 years. And I've worked on redesigns of this system. I'm probably on my 5th generation of this stuff, and still making improvements. The technology improves, and but it's a really harsh environment, as you can well imagine. Water wants to get into anything and everything.
And sand. Actually, that as you were speaking, I was thinking to myself that that you're in a very unique position to talk to us about technological advances over the course of your career and how they've shaped the designs that you've made over time.
Absolutely. Things have changed dramatically. That sled thing I saw in the last picture, we were so excited to be able to do that because in the past, the number of sensors we had on there, I think we had 64 different sensors on there. It would have been nearly impossible to wire all those cables back to shore. It would have been a cable, the size of like my thigh, and it would never have worked. But fiber optics came along, and we used a fiber optic cable, and we could send boatloads of data down that thing. Huge difference. Size and battery technology have affected oceanography and ocean engineering in a huge way. Electronics now, I have on the back of my latest version of the jet ski, there's a tilt sensor and a heading sensor that's about the size of my fist, that's completely waterproof, that I designed and built. And I never could have done that 10 years ago. It would have been the size of a suitcase.
So, and these technological advancements have come from other fields of engineering, right?
Yes,
that you're
absolutely.
incorporating in. So I guess maybe talk a little bit about that.
Yeah, definitely stuff comes from from other fields. It's mostly electrical engineering has been the biggest change. Just the miniaturization of everything, the communication, the data flow rates, the storage of data is phenomenal as well. I mean, all of you take it for granted that on a flash drive you can get 4 gigabytes without even, I think it's like $4 or something like that. When I started my career, 4 gigabytes would have been something the size of my closet. Never would have been able to collect the data that I wanted it to. So yeah, I'm an old guy, but those things that the engineering world has been pushing, electronics in particular, computers and electronics have reshaped ocean engineering. I can't even begin to speak to the volume of change that's gone on in my lifetime.
Cool. We have another question. Since many engineering careers are based in Silicon Valley and the Bay Area, how do you think that affects the job market since we are in the hot spot for certain lines of engineering work?
That's a tough one. I've only, since I've had my ocean engineering degree, I've only worked for 2 different institutions, both of them government. So I'm not a huge person to speak to engineering job availability in the private sector. But I can say that having that many around is almost like a synergy. It's nice to be able to call somebody on the phone and talk to them and get information, but I can tell you that there's a world of difference being able to walk to their facility, see what they're doing, talk to them about what you need and want, knowing that you're talking to a bunch of experts who have already done similar things.
Definitely, yeah.
So having that type of surroundings kind of builds on itself, and it just provides more opportunities for everybody.
Right. I wonder if a little bit of that has been lost with our work from home.
I think so.
Yeah. So what's this photo? Looks like you have a drone.
So this is a fairly new technology for, again, surveying, but this does, instead of the mapping of the water, this does the mapping of the beach on the surface, the land. It also is a very dynamic, as you know, you go down to the beach any given day and things move around. And of course, if you go at low tide, you can see more. So we try and do those jet ski surveys at high tide and the drone surveys at low tide. So these drones are programmed to fly pre-programmed routes, and they take pictures every second or so. Again, it's amazing that you could fit this much data on a drone. Like I said, 10 years ago, you would have needed a full-size helicopter to lift just the storage unit. But here it is happening now. And this black and white dot is a surveyed in position. And so when the drone flies over, it has what's called geo-referenced markers. And then they use basically stereotype photography to reference all of those points and create a three-dimensional surface. So they can, in 3 dimensions, map basically the beach.
So do you put these black and white things in different locations on the beach then?
Yes.
Is that what you're saying? Yeah, okay.
In this particular day, there were probably about 12, and we were doing about a mile of beach. So we would drive in that big truck and every couple hundred yards run out and stick one of these things out and then get a GPS survey the location and then move on to the next. Setting up for the survey probably takes a couple hours. The actual survey probably takes, flying the drone, maybe 30 minutes.
Okay, wow. And then just in our last few minutes here, do you wish that it was easier to research the ocean, or do you like the challenge?
That's a good conundrum. You know, as an engineer, you know, you're always trying to make it easier. That's our job, is to build things to help people's lives, and in my case, it's scientists' lives. So yes, I love the fact that I have a purpose to do that. Do I wish it was easier? Of course, I always wish it was easier, because then we could do more. Mm-hmm. And it's not like I'm looking for ways to do less. I'm looking for ways to do more. So if it becomes easier, that just frees me up to do other things.
What was your favorite project that you've worked on?
I love that beach work I was showing about. I've got to go to Alaska a couple of times now that I work with the USGS. I just wanted to show you one of the favorite things I got to do was fly on this airplane to meet a boat to do a seismic survey looking for earthquake faults off the coast of Alaska. And I got to fly in this plane. So that's high on my list of fun things to do. The other thing that I've had an absolute great time doing for the USGS is flying those drones. I became a professional drone pilot because of the survey, and that was part of my job.
That's
and the
so
other
cool.
thing they got me to do for work up in Alaska is they're always afraid about bears, polar bears and grizzly bears. And so whenever you're working out remote locations, it's a problem. And so they gave you a firearm training. And I had a week-long firearm training and shoot guns all week long. And I had never shot a gun in my life, and it was great fun.
Do you have to carry a gun then when you're in Alaska? Is that the deal?
Yes. In fact, we have a stash of guns that when you go to certain parts of Alaska, you get to check out and take with you.
Wow. And
they're not small guns. They want to kill bears, so they're big guns for all you guys who like big guns in movies.
So this class, I had an assignment to talk about some alternate engineering disciplines, and ocean engineering was one of them. And there seemed to be a fair amount of interest, and I think maybe your talk here has increased that. Do you have any advice of how students today could get into this field?
Yeah, how to get into the field. It's funny when I saw the question, what advice would you give your students? And I would say the biggest thing that I look for when I'm hiring people or on a hiring committee is the willingness to learn new things and to be humble. Because there's just so much that education can teach you. It gives you a good set of tools. I've always thought of engineering education as like a toolbox. They teach you how to use the wrench, they teach you how to use the hammer, they teach you how to use the drill. And then at some point you actually have to go build stuff. And then you may get a couple of chances to build stuff in your education. But the reality is there's guys out there who have tons more experience who can teach you tons more. And so being willing to learn is super important. There's nothing worse than somebody who shows up and goes, gosh, I already know all this stuff. I have this degree. That's real hard to to get them to do what needs to be done.
Yeah.
Ocean engineering, it's a tight field. There's not a lot of opportunities. I consider myself incredibly fortunate to be working in this field. But it usually means internships, doing low menial work. I mean, you've heard me describe even my job. At times I'm driving a truck. That's my job for 2 or 3 days. So you have to be willing to do just about anything. And probably suffer low pay for a while.
There's a question. Is that why some places take interns prior to receiving their degrees? I think a lot of places take interns prior to receiving their degrees to try you out, let you try out the work and see if it's a good match.
Yeah.
Yeah.
Something like Embari, there's not a lot of money in this field. So like I said, that's part of the problem. It's not like the private industry where, you know, I don't know, maybe I don't really know about private industry, but internships are usually either volunteers or you know, very lowly paid in the field of oceanography, ocean engineering. But yeah,
Okay.
they'll take, if I were to say there are any 2 degrees, if it wasn't ocean engineering, it would be computer science or electrical engineering.
As degrees you would recommend, or as degrees
Yes,
you
and
thought were
recommend.
right for you? Oh, recommend. Okay.
Yeah. You don't necessarily have to have a bachelor's in ocean engineering. You just,
Oh, you're saying to work in ocean engineering. You're
yeah,
saying electrical engineering, or what was the other one?
computer.
Computer
Yeah.
science. Thank you so much, Rob, for being here. Rob said he teaches Engineering 35. Is that right?
Yeah, I teach the lab course right now. Joanne and I co-teach the class together, Joanne Panzardi.
So you guys, when you get to that point in your degree, will have Rob as an instructor. He's also at Cabrillo. He has a Cabrillo email address. I'm sure he would love to talk to any of you more about all the stuff he's discussed today and other parts of his career.
I want to chime in one thing. I think Cabrillo is one of the best education values out there. I really do. I think that especially the engineering program, I think is top notch. So that's just my feeling of seeing it for a couple of years. It's a great school. Wish I had done something similar. Would have saved me a lot of money, and I think I would have gotten a better education in some ways.
Yeah, and really prepared you for what lies ahead.
Yep.
All right, thanks, Rob. Can we all thank Rob for being here? And if they have any more questions, I can email them to you, or they can email you directly even.
Yes, they can.
Yeah.
Rob, thanks.
Thank you so much. Have a great evening.
Bye-bye.
And I'll see you next week.
Yes.
Okay. All right. I hope you guys got a lot out of that.